Hi children, welcome to my YouTube channel. This is the first video of the video series Algebraic Fractions. In this video, we are going to discuss about least common multiple, or short form we call as LCM. I have focused about LCM in this video because most of the students get struggle when they are finding the common denominator in the algebraic fractions. I'll be starting from the basic concepts of algebraic fractions and LCM from this video series. Therefore, watch patiently because LCM is the building block of algebraic fractions. What is least common multiple? Sometimes it may pronounce as least common multiplier. If you get multiples of 2, you can say it's 2, 4, 6, 8, 12, 14, 16, 18, etc. Then we will get multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, etc. If you consider the common multiples of 2 and 3, you can see that 6 is a common multiple. Again 12 is another common multiple. Again 18 is another common multiple. So on, you can write infinite number of common multiples out of these two digits 2 and 3. Out of all those common multiples, what is the smallest value? The smallest value is 6. Therefore, simply we can say 6 is the least common multiple for 2 and 3. How to find the LCM? To find the LCM, we need to follow up 3 main steps. We can discuss the theory concept of finding LCM in this slide, but if you want to understand it clearly, we have to concern about one example. Step number 1. Write the terms as product of prime factors or with the smallest factors. Usually we write the digits in prime factors and algebraic term using its basic factors or the minimum factors. You can understand it clearly when we are working out an example, so don't worry. Step 2. Identify the common terms and write them. So you have to identify the common terms out of those the elements what you wrote in the previous steps, and you have to write them as common facts. Step 3. Write the maximum term out of the remaining term. This is a bit confusing. Don't worry. We will try to understand from an example what do you mean by this step 3 clearly. Okay, this is our first example. We need to find the LCM of 12 and 15. Step 1. We need to write 12 and 15 as a product of prime factors. 12 you can write 2 into 2 into 3, it's verified, 2 into 2 is 4, 4 is 12, so this is perfectly written over here. 15 is 3 into 5. Now that is the first step. Step 2. Identify the common terms and write them. What are the common terms here? So you can say 2 and 2 is available in the first term, but it's not in the second expression. Therefore, you cannot write 2 as a common term, but 1, 3 is common. 3 is common for 12 and 15. So you have to write 3 as a common term. So the common term, you can understand some of the students do this mistake. They write 3 and 3 2 times, but the common terms you need to write it only once. Therefore, you can write the common term as 3. Step 3. Write the maximum terms out of the remaining terms and multiply them. Then if you take that common term 3 out from 12, what is the remaining term? Remaining term is 2 into 2. So you can write 2 into 2 with 3. Then what is the remaining term out of 15 if you take 3 out? That is 5. So you can write 5 as well. Therefore, you can get the LCM as 3 into 2 into 2 into 5, that would be 60. Simply we can say LCM of 12 and 15 would be 60. In this example, we need to find the LCM of 24 and 32. Step 1, we should write 24 and 32 as product of prime numbers. You can write 24 as 2 into 2 into 2 into 3. 2 into 2, 4. 4 into 2 is 8. 8 into 3 is 24. So it's verify. 32 is 2 into 2 into 2 into 2. That is 5 times of 2's. Right. Then identify the common term. So you can say the blue color one. The first couple of 2 is common. The red color one. The next couple of 2 also common. The yellow color one. Next couple also common. So you can understand the common terms would be 2 into 2 into 2, that is 8. So we will take that 8 out from the expression 8. If you take 2 into 2 into 2 out from 24, the remaining term is 3. So you can write 3 over there. Out of 32, if you take 2 out, another 2 into 2 is remaining. So you write both of those 2 as well. With that, you can write the LCM as 8 times of 3 into 2 into 2, that is 96. This example is something much important when you are finding this LCM. The question is to find the LCM for 24, 32 and 80. Then let's write 24 as product of prime numbers. 2 into 2 into 2 into 3. 32, if you take it, 2 into 2 into 2 into 2 into 2. 5 times. Then 80, 2 into 2 into 2 into 2 into 5. Then identify the common terms. The blue color line, 2 is common. Then red color line, 2 is common. Then yellow color line, 2 is common. Then you can take the common terms as 2 into 2 into 2, 8. Then getting the remaining terms for this expression. You can see 3 is remaining from the first step out of 24. Then you can add 3 to this expression as into 3. Then the second expression, there are 2 2's, 2 into 2. And in the third expression, there is only 1 2. So in such situations, we take the maximum number of 2's in this expression, in a one expression, sorry. So in the second expression, there are 2 2's. In third expression, there is only 1 2. Therefore, you have to take only the number of terms with the maximum occurrence. So you have to select 2 into 2 as the remaining term, and then we are not selecting the rest of 2 in this expression. That is the other important point we have to understand when you are selecting LCM. That is why I mentioned in the step 3, write the maximum terms out of the remaining terms and multiply them. Then another 5 is remaining in this expression. With that, you can write the LCM as 8 into 3 into 2 into 2 into 5. And you can write the final LCM as 480. In previous slides, we have already learned how to find the LCM for digits. Now we are going to concentrate how to find the LCM for algebraic terms. In this example, we are expect to find the LCM of x squared, y and x cubed. Let's expand these expressions and write at the first step. X squared y, you can write it as x into y. X cube, you can write it as x into x into x. Then identify the common terms. You can see the red color x is common and blue color x also common. Therefore, the common term would be x squared, that came from x into x. Then write x squared, then write the remaining term. From the first expression, what the remaining term would be y, and second expression, the remaining term would be x. Therefore, you can write x squared into y. X cube y would be the LCM for these two terms, x squared y and x cube. Here we need to find the LCM for 6y squared x and 8x cube. If you write 6, that is 2 into 3, y squared x, you can write x into y. 8x cube, you can write 2 into 2 into 2 is 8. X cube, you can write x into x into x. Now try to identify the common terms. So you can see one set of 2 is common, that is represented in blue color, and one set of x also common, that is marked in red color. Therefore you can get the common terms would be 2 into x, 2x. Now write 2x at the corner, then I try to identify the common terms. So in the first expression, the remaining terms are 3 and 2y's. 3 into y, 3y squared. So you get them as a common term. From the second expression, 2 into x would be common. So you can get that one also as a common term. Finally, you can find the LCM as 2x into x into x into y into 2 into 2 into 3. That would be 24x cube y squared. That would be the LCM for these two expressions. In this example, we need to find the LCM for 4y cube x and 8x cube. If you take the expansion for 4y cube x, that would be 2 into 2, that is expansion of 4. Y cube would be y into y and x over there. Then 8x cube is 2 into 2 into 2, that is expansion of 8. X cube is x into x into x. Now identify the common terms. 2 into 2 and 2 into 2. Two couples of 2 would be common and another x would be common. Therefore, you can take the common terms as 2 into 2 into x, that is 4x. Then we are going to add the additional terms. From the first expression, the remaining terms would be y into y into y. From the second expression, 2 into x would be the remaining terms. Therefore, if you take them out, you will receive the final LCM as 4x into x into x into y into 2, that is 8x cube y cube. If you are going to find the LCM for x plus 1 and x minus 3, so you can say if you write x plus 1, there is no expansion, you can just write it as x plus 1 itself, x minus 3 also the same. Then you can understand that there would be no common terms, so just keep it blank and you can add the remaining terms, that is x plus 1 and x minus 3. Therefore, the LCM for x plus 1 and x minus 3 turn up into x plus 1 into x minus 3. Hopefully you can understand this section. In this example, we have to find the LCM for x plus 1 squared and x minus 3. So if you work out x plus 1 squared, that is x plus 1 into x plus 1. So you can keep it as bracket form, and x minus 3 is just x minus 3 as in the same question above. There are no common terms, so you have to add only the remaining terms from the first expression, x plus 1 into x plus 1, and from the second term x minus 3 only. Therefore, the LCM for these two terms x plus 1 squared into x minus 3 would be x plus 1 squared into x minus 3. Okay children, now we need to find the LCM for x plus 1 squared and x plus 1. If I write x plus 1 squared, you can write it as x plus 1 into x plus 1. Just x plus 1 is there is no expansion, just you can write it as x plus 1. Out of these two expressions, one set of x plus 1 is common for these two terms, which is marked in blue color. Therefore, I will take that common term out. If you take the common terms out, x plus 1, the remaining terms would be just another x plus 1. Therefore, you can write the LCM as x plus 1 into x plus 1, that is x plus 1 squared. If you need to find the LCM between x plus 1 squared and x plus 1 into x minus 3. If you expand x plus 1 squared, you can write x plus 1 into x plus 1. X plus 1, x minus 3, you can write it as same thing as it is, x plus 1 into x minus 3. Then you can see x plus 1 is common. If you take x plus 1, the remaining term out of the first expression is another x plus 1. You can write it, and the x minus 3 would be from second expression, so you can write x minus 3 as well. With that you can write the LCM as x plus 1 squared into x minus 3. In this case we need to find the LCM for x plus 2, x minus 4 and x plus 1. Therefore, if you write them, those two terms are repeated only once. Therefore, x plus 2, x minus 4 and x plus 1 come up to the terms for these expressions, and there is no common terms, and you can write the remaining terms x plus 1, x plus 2 and x minus 4. Therefore, you can write the LCM simply x plus 1 into x plus 2 into x minus 4. Hopefully, you can understand how to find the LCM for these algebraic terms. Hope you have enjoyed the video and understand the contents clearly. If you like the video, put a thumbs up. Share this video with your friends, and to see more educational video, please subscribe my channel and click on the bell icon. See you from the next video.